What do you say we get to assembling this giant scale Cessna 310? All right, so I'm going to remember to put this at the beginning of this build series so it helps you to make a decision. I'm going to put it in the front of all the videos that matter, but we're just about done and wrapped up with the Cessna 310 project. The problem is, though, one of the very last things that I have to do is a problem, and it's not an easy solution. So let me show you what I'm running into. So basically, I wanted to run the master air screw counter-rotating props. So we have a counterclockwise, we have a clockwise. Those Sunny Sky motors just don't have enough shaft to put a washer and a nut. And I guess I kind of neglected that, figured I'd find a solution to that, and I didn't. I was hoping I could just buy longer hubs, but they're just not out there. So I'll hold on to these in case that's ever a thing. I did find, though, let me show you the spinner. All right, we have 3-blade spinners from Gator. I showed you guys that. So if you want to do that one, you can, right? Here's the problem. I come over to this one, and I got a counterclockwise spinner for a clockwise prop, and that don't work well, and I can't find a clockwise one of these anywhere. So with that being said, I'm stuck. So if you want to run the Sunny Skies, we're going to have to switch to a 2-blade, and then you're going to lose counter rotating as well. But I can go back to the regular spinners that came in the kit. So I'm not going to get counter rotating props. You know, it's kind of a bummer, and I'm not getting 3-blade. In the unboxing video, a couple guys mentioned, well, 2 for show, or I'm sorry, 2 to go, 3 for show, and that holds true, right? You're going to get a little more performance out of those, and that's what the full scale has, is a 2-blade, but I like the look of a 3-blade, and I like the idea of counter-rotating props on this. I'm just not going to get it. Now, if you want to run the Avian 5065s, you can, and there are uncut spinners out there that you can get and do that. So I'm not going to swap my motors out. It's too late for that, and I'm too far into this. And I'm going to have to pick and choose where I'm going to go with this. And where I'm going to go is I'm going to go with a 2-blade, go back to the factory spinners at that size and leave them there. The ones you can cut are about 5 mil shorter, but the electric prop solely is a lot thinner on the 2-blades. So much better overall. But there's the update. Hopefully that helps you guys with your build. Welcome everybody back to the channel. I'm Brendan. Thanks for joining me for another episode down in the layer. And from Seagull Models, this is the giant scale Cessna 310. 81-inch wingspan, 15 to 20 cc engine requirements, times 2. You can go electric or you can go gas. So we are going to start to go through the assembly process and kind of show you guys how I put things together and how I choose to do things. And hopefully if you picked up this model, it'll help you along the way. If not, maybe it'll drive your interest towards this one or something else from Seagull. With that being said, destruction manual, you can use this for guidance, seems pretty decent. A couple things to note for me: I am not going to be using the included light system in there. That is a 12-volt light system. I don't like mixing voltages, so I'm going to use UniLights. They're on order and they're on their way. So we're going to incorporate that a little bit later into our assembly or build if you want to. The other thing is we're going to get started right out of the gate with fixing wrinkles and pressing covering in and things like that. So one of the things that I like to do is take the heat gun to it and then use my hand with a hot glove on it and press that in. I think that almost works better than taking the iron over it, because you can really kind of work that covering down into there. You don't want to focus on open seams too much with that heat gun, because it'll pull those lines away when it shrinks the covering. So just be very careful around those areas. But with that being said, we're going to get rolling. We're going to do our version in electric, so that way we can have counter-rotating props. And I'm kind of excited to see how this thing comes together, but should be a very cool project. So let's start time-lapsing. All right, so as you go ahead and take the heating iron to your project, make sure that you get all of these seams pressed in really good. These are the areas that, especially if you're running gas or something with smoke, anywhere where that covering isn't really tight and pushed down in, it gives the ability for stuff to wick in there or develop wrinkles in there. So really get that heating iron worked in on those edges really well. So let's talk about wrinkles for a minute. So you can see right in here we have some wrinkles in the covering that we have to get out. What causes that? Well, it could be that the covering wasn't put on tight enough when the model was built, or it could be if you're dealing with something like an ARF. This thing was built overseas in countries like China or Vietnam, where they have, you know, really high humidity areas. So it's balsa wood. It absorbs the moisture. It swells up. When you put the covering on, it's nice and tight. Come over here, we're down in the layer. We have a dehumidifier that runs down here all the time. All the moisture is pulled out of these things, and before you know it, you got wrinkles. So one of the ways that I like to get rid of wrinkles is we're going to use the heating iron with a hot sock. And it doesn't mean that there's an issue with your model or my model came with a lot of wrinkles, it's no good. You know, these are simple fixes that will really just kind of build your modeling skills. So how do we deal with those? Number one, anywhere where we have a seam, like you could see this blue by feel is laid over the white. The white comes down into here, it was trimmed off, the blue overlaps it, which is nice, but we have a wrinkle. You want to be very careful in these areas that we don't take the hair dryer, all right, the heat gun, over that edge and just blast the snot out of that, because it's just going to pull that edge away and it's going to suck it back. And then you're going to have this weird mark in there, or the covering's going to wrinkle and burn, that type of stuff. So I use a combination of the two. So if it's a flat area where I don't have to worry about the edge peeling, I'll take the heat gun to it. I have a hot glove and I just work it, pushing that stuff down. If I'm dealing with an edge like that, I have my sock on there, which clean socks are very important. You could already see there's blue on there. You don't want to get it all over your other model. And I come in here and I start working at that edge. And even like if you see like here wrinkles starting to develop, you can take that over the top lightly and just let this thing kind of suck that wrinkle down, and then you can push it down into the wood. The goal is to get this covering to shrink, but it's also to activate the glue underneath so you can make this thing stick to the model. So when it gets hot, none of that covering wants to lift. So you can see as I start to just lightly rub this thing over, you can go over the whole thing if you want to, right? And then we just come back and we keep focusing on that edge to get that edge sealed down. And we're just going to work that over until you see that bubble disappear. And then you can kind of keep working that thing down through all the covering. So again, just get it nice and warm. If you see those bubbles, then we take that hot hand and we just start to press that down. You want to be very careful if you have a wrinkle, don't just push down on that wrinkle, because then what you're going to do is just wrinkle the covering and shove it down into the wood and you'll have a wrinkle you can't never get out. The goal is to shrink out the wrinkle before we press it down. And there you can see that. All right. So we'll do over to white right here. Again, let this thing kind of move around, but let that heat build gradually over that covering. And then we can work that area down. So from there, right, pretty much all of my wrinkles are out, and I think I have it pressed down. So here's now where I'm going to take that nice hot hand here, make sure we got some heat, and again I'm working away from the edges of stuff. Now we'll come back over that blue. Again, I'm working towards the edge, and we're going to press all that covering down. And I mean, that covering's hot at this point. All right. And that gives you a good idea what I do to all of my models. And you may miss a few spots and you may have to catch up with them later, but that will keep most of your model from wrinkling. So I hope that helps you guys. All right, let's go ahead and start hinging. So one of the things that I do with my surfaces when I pull them off is I make tape marks. So that way we always know what pieces go together. So you never glue the wrong one on the wrong side. There you go. You could see that. All right. So now we know where those belong. So for hinging, a couple things here. So using row-barred hinges, we're going to use some oil here, and we're just going to work that into that hinge gap right there, the hinge itself. So that way we don't have any epoxy stick in there or whatever it is that you're using and causing you issues. We don't want that stuff to get stuck. Do not get the oil on the barbed part of the surface for obvious reasons. All right, and give it a wiggle. So from here, I used to use, typically do use, the expanding foaming Gorilla Glue, because it'll fill in around those barbs and those pockets and it creates a ball on the back side. You'll never pull it out and you'll never break down. And in my prior videos you could see where I do that, and like my X Cub, if you want to see what that process looks like. So you just dampen the holes, you put a little bit of glue on there, put it in, and then it foams out. Usually you'll have to put a little Vaseline or something around there for as you're beginning to use this, and you realize what too much is, it'll foam out and then you have to pick it off and it becomes a pain. So I use a little Vaseline around the holes, makes it easier to flake off. So I'm going to epoxy these in for the sake of time because I got a ton of airplanes to get done in a very short order for upcoming shows and things like that to put on display. So I got to get moving with this one a little bit faster. So here we're just going to use epoxy. And a lot of people ask what's in the gun. This is just West Systems epoxy. So this is their 610. This is the thick stuff. So it's 2-part. You can put it in here. It's slow cure overnight, which is what I like. I don't want this stuff to fill up too quick. So let's go ahead and time lapse. We're going to go and fill in all of those, wipe a little on those, put it in there. Then when we put these in, we're going to put them in and we're going to line them all up so they're straight and straight upright. So they should all fit at a 90-degree angle from there. All right, and all be not that way, not that way, this way. So that is the goal, and then we're going to work it. As far as these things, I always remind everybody as we put those in, scruff them up. Really abrasive sandpaper there. Okay, and I tape around my surface, and we're going to take this thing and we just drill one hole. That give that epoxy something to bite into. So let's get that installed. We want to try and get this lined up. I did preliminary test fitting. We want that hole right on the hinge line, so that way you get the most neutral movement from center, that it's the same amount of throw in your transmitter this way as that way. That's the goal. So let's go. All right, let's go ahead and get our fiberglass hinges put in. One of the things that you want to do, you notice how they cut the corners here, that makes it easier to slide into the surface. We want this thing to be centered equally on both halves. So I put these little pins in here. These are just clothing pins. You can get these from like a Walmart, anything like that. So this way when we go to slide those in, they stay centered. The other thing that this will do for us is give us a track for our thin CA to kind of wick down into. But this way you know that they stay nice and straight in our slots. And we're going to slide this one in. Now, one of the things that other people do is they'll use a crayon to make a center line, and that would prevent CA from wicking into the center, and then you could visually see it as well. What that's going to do is keep that super flexible hinge line right there. I've never run into any issues where I've had any break. Doesn't mean that it will or won't. Just going to be preference. So let's get this thing slid together. All right, now that we have those slid together, you could see how the pins sit and they give us a little bit of a track. We can actually run the thin CA right down those little pins so it wicks into there, so it acts like a track. Some people like to glue in one side and then do the other. I personally don't. I want the glue to wick in and go wherever it wants to go. If this was an elevator half, one of the things that I like to do is the bottom first, and that way that hinge is its most absorbent at that point, so it'll soak in and hopefully you don't get any run through to the other side. And then I'll do the top last. I also like to keep a little bit of debonder on hand in case you get overrun onto the covering. If you use this, usually you can get it off. So always keep an eye on your lines here. So we want to make sure we have enough clearance right there, as well as we follow the tracking of the lines on the top. You also want to make sure that your gap is nice so you get full deflection, and that's one of the things that we are going to get from those pins being in there, is a nice uniform gap. So there is really no bottom to this. I like my hinge line right there. So let's just go ahead and take, and we'll put a couple dabs down in there. Okay. Give it one good push in. Right up against those pins. Everything moves nice and freely. We're going to flip it over and do the other side, and we're all done. Hope that helps you with your fiberglass hinges. So now we're going to get our engine pod put on. 2 screws there, 2 on the insides into there. We're going to use the 4mm bolt with a washer and Loctite. Make sure you use the 399L on the left wing or on the right wing. All right, when you do this, be careful you don't over tighten those. Make sure plenty of blue thread lock. Like when you tighten these down, you can hear noises happening. So don't get too overzealous with those. And these screws are really nice because you can go in through the side and get to those, and make sure those get tightened up really good. This may even be something afterwards that I chase this with a little epoxy or something else, canopy glue or something, just for vibration, so those don't come loose. I don't think a lock washer would be a good idea there on the wood. Blue Loctite should be ample. If you want to use rubber anti-vibration washers, you're going to need longer screws. Because of the thickness of everything, those aren't really long. They're ample though. All right, to attach the motors, something I want you to keep in mind with these engine nacelles over here is they face outward. So you have right thrust and essentially left thrust. And if you do a little bit of research, I found that there's a ton of differing opinions on P factor, gyroscopic rotation, which way those should be. But it is normal to have on a twin them both facing out thrust to cancel. With mine running 2 motors, I'm running these Sunny Skies. These are the 4130s. They're 380 kVs. These things, I'm going to do one rotating one way, one doing the other, so clockwise, counterclockwise. And basically all this thrust we're going to wind up taking out in this motor box because of doing counter-rotating props. They kind of squash the P factor thing, and you can make them straight. A little bit of down thrust, 1 to 2 degrees. So that's what we're going to opt to do with these. we have them set in here. I'm going to just look in the back. You could see the little crosshairs. I'm going to get the motor shaft centered in the crosshairs, flip it over. We're going to mark the bolt locations, drill them again, and then we're going to bolt and lock nut on the backside. Now, when working with the Seagull boxes, remember, this is all adjustable, and you don't just want to willy-nilly epoxy that thing into place. So what I do is I drill holes through the ears, and now we're going to go get some wood screws, and we're going to tighten that up on the shoulder to hold that into place so we can make adjustments. Then we'll epoxy it. And you can even leave it like that for the maiden flight, so that way if you want to make a change afterwards, it's easy to do that. As far as the down thrust goes, we're going to leave this just snugged up with our depth set to 140 millimeters from the furthest back edge to the edge of that hub. Motor straight now. We're going to tighten that down. Once the wing is mounted on the plane and I have the plane leveled, then I'll go ahead and I'll set in about a degree of down thrust. You'll also see that I use some spacers right in there. It's about 4 millimeters worth just to get me that extra little bit I needed to get this past that cover, that nacelle cover that's going on here. All right, the nacelle covers are right and left. So how do you find it? You want to look at the top. So our thrust on the engines is facing out on both engines. So left on the left, right on the right. So if you look at these, that taper should taper away from the center of the engine. So this one tapers this way. That makes it the right-hand side engine because that engine's going to face out. So there's a couple things we're going to get ready to do now. We're going to go ahead and mount the flap servo in there. That will go there. You will also have 2 of these control horns. We've gone ahead and drilled and scuffed. Those get glued in to there. All right, and that is for your split flaps underneath. So we're going to glue that in. We're going to put in that servo. And then the cover here, since this is our left wing and we're using our marked left nacelle, that thing's going to get slid over. And I think I'll save it for, obviously, the maiden to give you feedback, and hopefully it don't burn me. But being that these nacelle covers are also tapered, this is actually a really, really good fit on here, by the way. So that slides in there like that, and you just got to get that piece lined up. See them screw holes right there? So those are going to have screws come in from the bottom into there, just normal wood screws. Again, fit is really, really nice on this. So we set the depth of our motor to 140 millimeters. We'll work this on. All right, I had to fidget with that for a little bit there just to make sure it was on and not break it and move the camera out of the way. So depth on 140 millimeters is good. The fit here on the back is perfect. And now, so let's look at what it is that I see here. So as much as I want to, I don't know that I'm going to have a choice. I think I'm going to have to leave that right thrust into this, or the outside thrust, left and right, into this. And does it make a hill of beans whether or not I use a rotating or counter rotating on each side like I want to? No, I really don't think it's going to. Again, what we're trying to offset is left yaw. So if they're both motors are the same and spinning opposite directions, same is the same. I think ultimately I'm going to wind up putting that thrust back in it, that outside thrust. I don't think I can go straight unless I shift that whole motor box over. And I don't think it's going to be worth it because I don't think it matters. So I'm going to shift it, and I'll let you guys know how that works out. But otherwise, once that's locked into there, they have you measure up 70 millimeters in here, drill a hole. You're going to put a screw through there. I'm going to use a Viton washer on the outside of that, so that way it grips and it doesn't want to break it. Then make sure you harden that sheeting underneath with thin CA. And then on the flip side, we're going to put those screws in. So got some screws to do, but we're going to loosen that motor up and adjust it the way we want it. And then flap servo, and we're going to glue in the horns. So one of the things I'm going to do, now that I have the screws on the side of that motor box installed, we're going to take our spinner back plate, put your bushing in there, slide that over, and then that'll give you a good reference line to the angle of your nacelle on how you want to position that thing. We're not going to get away from having the out thrust on this, because if you make them straight, it pushes the motor way over here, and it's going to leave a really bad big offset over here. So I am going to still stay with clockwise, counterclockwise rotating props. I'm going to leave them out, which is, according to a lot of the stuff I've read online, that's kind of normal for twins, that they do that to counteract the P factor by placing them outwards. But also that happens when you do clockwise and anti-clockwise rotation props. So I think I'm going to be good. I don't think it's going to matter just because these are both splayed out. It'll keep the look appropriate, and I think it'll fly just fine. So I'm going to get my spacing the way I like it here. I'm going to tighten those motors down now for good reference, and I'll probably try and just make sure that I like the way they look before I glue in those plates. So, all right, so that looks good. Let's take it back apart, tighten those screws down. For our flap horns, those things, when they drop down, they drop back. So I glued mine just about all the way front. I left a little bit of spacing in there, but that should give me all the articulation I want without any rubbing. All right, in our Seagull model Cessna 310, we are going to be using FrSky Exact servos. These are the 5401s. So let me take this out and show you guys. Of course, plain and servos available right here at Gator-RC. If you're looking for the website, it starts with the three of the same letters, .gator-rc.com. So 8.4 volt capable, 316 inch-ounces of torque at that voltage. These are soft start, aluminum housed, all metal gears. They are programmable through the Ethos suite and the FreeLink app. So you could program different things to these. They're also telemetry capable on FBus. They do work on PWM, FBus, SBus, 25 geared, tooth geared servo. So they are compatible with a lot of different servo arms that are out there on the market. But ultimately, telemetry wise in FBus mode, these things would put out temperature, voltage, amperage, stuff like that. So comes with a nice little hardware kit. We'll go ahead and throw those grommets on right there. We are using these across the board in this Seagull model Cessna 310 project that we're currently working on. So if you haven't been following along in the build, make sure you're subscribed to the Gator-RC YouTube channel, the Just Plain Crazy YouTube channel, and Facebook on both of those as well. So with that being said, easy way to put these in. The little hats, the flanges, go down at the bottom. I use a flange drill bit, just like this. I've been showing this in every build video because it's always helpful. And then just come in through the bottom right there to install those here and there. So there you have it. That servo, that is our 5401 FrSky Exact standard servo. It's ready for install. All right, so now we're going to take this thing, we're going to stick it down in there. The gear is going to go inboard, like so. It's going to fit down in a little notch down here into the side. It's a pretty tight fit. So there's that. Now we're going to go ahead and pre-drill a couple holes. All right, now we go ahead and we take that out. And you guys should do this for every servo that you have. All right, we're going to get some glue in and around those holes. Strengthen the wood, strengthen the holes. We'll give that a minute to dry. And then you guys should see this little Fantic crazy electric screwdriver I got. It's not the strongest one in the world. I got the Pro version. Comes with a bunch of different bits and stuff in here. I don't promote these things, but I got tired of doing the manual thing by hand. So I now use that, and I really like it. It works well. So give that another second to dry. We'll fish the wiring in through the pocket. That's good. That's in there. I'm sure you guys can see. There's that. Has a nice little extension bit here for the 2 mil. Works pretty good. Like I said, it doesn't take everything apart. It's not the strongest cordless screwdriver, but it's slender. And it really helps to save some time and stuff like this. And I like the long reach. The button, I almost wish the button stuck out a little bit more. It just make it easier to find with your thumb. All right, there you go. Flap servos installed. We're going to go ahead and get the nacelle set on here and get our motor angle set. All right, lights have arrived for our tip tanks. It was funny in my unboxing video, I forgot what these were called. And sometimes when you shoot videos, it just doesn't come to you. So you guys were very helpful in the comments, and you didn't beat me up too bad. I appreciate that. So anyway, red is going to be on our left wing. We're going to put in the nav light in here. So there is the part number. It's down in the description too, if you don't find it there. Okay, so I like these. These work really, really well in these types of applications. I put them in my Seagull model Corsair as well. I love UniLights. I just, if you're gonna have lights in a model, you know, it obviously it comes with lights, but I like really, really bright lights. I like stuff that's going to just really, really stand out. So we just take that thing and we fish it. Do-do-do-do-do-do-do. There's that. Just tuck the wires through those little holes. And now, like, I can go ahead and mark where I'm going to put those, so that way I'm not pinching that wiring in there. I can open up those grooves a little bit, just using a Dremel. But then just 2 little tiny screws, or you can even just epoxy that whole thing into place if you want. I'm going to use 2 tiny screws through there to fasten it in. And then here's the lens cover, right? And this thing will just get glued in over the top of that. And look how cool that's going to look, like clean. That's what we're going for. They do make these so you would have both nav and strobe if you wanted to. I just want nav in here. We're going to do the strobe in the back, and then that's going to be it. Okay. All right, now for throwing on the lens cover, let's get ourselves a little bit of alcohol. Start with a shot of Jack Daniels, and then let's get back to the project again. Rubbing alcohol, guys, rubbing alcohol. Clean that up good. Get off any of that oil and film on there. And then do yourself a favor and wipe out the inside of your lens assembly. Like so. All right. I love using canopy glue. The only downfall of canopy glue, it's going to take a while. So just don't overdo it. All right, so we got a bunch of tape here. Just set some tape off to the side for there. And if you want to use screws, feel free, go ahead. But this does not take much. Do not overload the canopy glue. And the nice part is if like you use too much, you can clean it. It's water soluble. It's alcohol soluble, right? But it just makes a mess. All right. So there's that. Now we're just going to take this thing, going to drop that down into position. Make sure we get our point nice and sealed. I'm not going to push too hard down on this thing. And we will seal up that edge. Now, just let this sit for a while, and you can actually go ahead and install it if you wanted to. The thing's not going to go anywhere. So we're going to get to working on that. Let's go ahead and get in our wiring fished in with our tip tanks. So for now, we're actually just stuffing it in there. It'll be easy to grab. Those pieces all just line up and it slides in. Might have to tweak that hole there and clean that up just a little bit. All right, now we're going to use a 4mm bolt, and I'm going to use a Viton rubber-backed washer so those don't come loose. A little bit of Loctite. And all I did was just round that hole so it wasn't slotted, that it was actually round for the bolt. Now, one of the things that we'll take a look at is trying to make sure that we got this thing pushed in as much as possible there, and we're going to tighten it up. All right, now the normal release or relax of this material, this fiberglass up against the wood, like if you bend or flex this way, you can see as it's relaxed, there's a little bit of a gap right there. If I pressure it just a little bit, then that gap goes away and it's nice and sealed. So I'm not really sure if I just want to pipe in some epoxy in there and just glue that fast like that, and then you'll never notice the difference, or use a little bit of CA, or maybe just a piece of clear 3M tape right over the top, so that way if I ever want to remove these pylons, I can. I don't know in what world I would ever want to remove those again if need be. So I don't know, we'll think about that. We'll let it go for a while, but our lenses are drying here on the ends of our tip tanks. We'll see how we want to address that to clean it up. And it's not bad. It's just my attention to detail, and what I like is different from other people. So, but anyway, we'll figure out what we want to do there off to the next steps. All right, for the white strobe at the back, again, I'm not using their wider lights, UniLights. I had this black spacer housing from like a generic light kit, and I just kind of grooved it so all that fit in there real nice, and that'll take up that space. So I fished the wire through, and then just like we did with our other lights, we're going to go ahead and use a little bit of canopy glue here around that edge. We'll get that thing pushed into place, and then just a little bit on the light assembly there too. All right, nice. Get this cleaned off, wiped off. All right, elevator halves are ready to be epoxied into place. We have to put in our horns, and again, Robart style hinges, same as our wings. Something to keep in mind, again, I always tag all my surfaces before I pull them apart. You don't want to get this side over there, and nonetheless, you don't want your horn to be up on the upside where it should be on the downside. So a simple piece of tape fixes all that. But otherwise, let's get everything hinged just like our wings. All right, for our horizontal, we're going to go ahead and we're going to harden the ears right there. So you don't need to go crazy, but just to give those things a little bit extra. Just like that. And all it is just to, you know, harden up those tabs. But what I don't want is I don't want to draw in the horizontal into the side of the plane. Don't use bolts and roll it in. Make sure that fits flush and you're tightening against those. They're just tabs. They're just there to hold. They're not going to draw this thing in. You'll break them off. All right, now we're getting ready to glue the vertical into place. We have the horizontals into place. We're just using a cheapy laser on a stand there. We got the plane leveled. You can, man, that thing's sensitive. So there's that. All right, so that's all good. Now we shoot the laser from the nose all the way up the vertical to make sure the vertical is perpendicular, I guess is the right word, to the horizontals. Seagull did a great job of making sure everything is square. I made a mark where I'm going to glue this thing over. And normally what I do is I'll heat all this covering down and I'll cut a little strip and I'll epoxy that down through there. I think I'm just going to make, because this has a huge box back here to glue in. So all I really need is just a small dowel pin up here, make an impression, drill that, and then I can epoxy that into place. So anyway, I'm really happy with how square the tail is and stuff. Let's get to popping this back out, epoxy in the box, putting it back down in. All right, there you see the little dowel pins I just glued into the end. We're going to put this into place, and I'm just going to line it up and make an impression, and then I know where to drill my 2 holes in the top. All right, it's time to put in the retract. During the unboxing, we talked about why they epoxied all of this in the inside of there. I couldn't figure it out. I just thought they did it for grass and water off the wheels, whatever, so don't soak in and ruin the wood. But the thing is with the retract units, see that circle right there? That circle is needed because when this thing comes down, that's going to hit here, right? And you need the wheel collar on the end so it don't poke through. But don't even go that far with it. Don't do that at all. Don't mount this in here without the tire on it, because what will happen when you have the tire mounted on here, this tire is going to come down and it's going to hit the edge of the sheeting and it's going to stop it. So that's actually going to fall short of even getting there. If you don't have the tire on and you do this and you actuate these, you're going to poke a hole right through the covering, and it's going to be on the top side. So do that. Then the other thing I am going to do before I go much further is I am going to inlay carbon fiber weave. So I'm going to pop this out, and I'm going to cut myself a bunch of weave, and I'm going to lay that in there. And the reason I'm going to do that is so that way over time of that wheel pushing on there, and it's not a lot of force, just a little bit, right? But I just don't want any pressure on there at all. This carbon, when it hardens, is going to solidify this whole area, so that wheel pushing on there isn't going to have any effect on the sheeting or the covering that would be on the top side of the wing. So these things, this is really nice. They are countersunk, so I do use countersunk 3Ms. I buy these kits off eBay or Amazon. I'm just going to use those in there with some thread locker. That'll work nice in there. Let's get this carbon, though, inlaid, and then we're going to get the wheels on. So let's talk about wheels for a minute. Wheel collars. All right. When you go to use wheel collars on the inside, as long as that tire doesn't need to be spaced away like that, you really don't even need to put grub screws. They can free spin in there if you want. I'm still going to make a flat spot. I'm going to flat spot it here and here, and I'm going to get that tight. Before I slide my wheel collars on, I'm going to put a dab of canopy glue here and on that grub screw that's in there. I have never had a wheel collar come off in my life, and that's just because when this solidifies, it gets rubbery, and that vibration dampener effect, if you will keep it from coming loose. Then we're going to go ahead and we're going to put this on, and then we're going to grind that spot away, and we're going to slide on another wheel collar with a little bit of canopy glue there, and then when that dries, there ain't no part of that that's going to fall off of this thing. So that's what we're going to do, so when you see it in the time lapse, you know what's going on. All right, and here you can see that wax paper just laid over the top of the carbon. You can actually rub that through to make sure it engages. To activate the retracts, we're just simply using one of these Amazon controllers with a battery there, and we're just going to activate it and put the gear down. There. And it's not much, but just that little bit of pressure right there. I don't want that sheeting to move, and now that'll form around that wheel well. And there you guys have it. That wraps up this section for the build or assembly, if you want, of the Seagull's model Cessna 310. Again, 81-inch Balsa ARF available right here at none other than Gator-RC. This thing is turning out to be a cool project, as you can see here. But with that being said, I appreciate you guys for joining me for this portion. Do me a favor, hit that thumbs up. It helps us out a lot. Shameless plug, right? Like, share, subscribe. We can't do this stuff without you. So with that being said, give us one of those. If you're going to give me one of these, I'm so bad I deserve 2 of those for sure. And don't forget to follow along in both the Just Plain Crazy and the Gator-RC Facebook pages. All right, lots of cool information that comes out on there. If you're not signed up for the newsletter, go and do so you're made aware of shows, specials, sales, all those kind of cool things. But if this model may be in your wheelhouse or maybe something close to it, don't forget to head on over to www.gator-rc.com, your one-stop hobby shop for models, gear, engines, motors, and electronics, all the like. So full line of Seagull's models, Seb Art models, and top RC models. So if you want composite, you want balsa, you want covered, you want not covered, you want turbines, man, we got it. So don't forget to go over there and check them out. Links down in the description below. But that being said, I got to get out of here. We got stuff to do. So I will see you later, alligator.